Hello friends, this video on light, reflection and diffraction part 19 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 18 before going ahead with part 19. So with this we conclude the second half of this lesson. So in this entire lesson we studied about the phenomenon of reflection and refraction of light, and we also studied about image formation by spherical mirrors and lenses. So let us now try to solve few problems based on whatever we studied about refraction of light. A concave lens of focal length 15 centimeters forms an image 10 centimeters from the lens. How far is the object placed from the lens? So in this case, what are the values that is given? Focal length is given as 15 centimeters. For a concave lens, focal length is negative. Image distance is given as 10 centimeters, right? So first let us try to plot the ray diagram. This is a concave lens. This is the principal axis. Now let us suppose the focal length F is here. This is my object O. So what happens? One ray of light passes through this optical center, goes undeviated. Another ray of light parallel to the principal axis after refraction get diverged. So when it is joined back, both meet at this point and this is the image formed. Right? So in this case, my image is formed at this point. So V is also negative because it is on the left hand side compared to the optical center. So we have to calculate the value of U. So we will apply lens formula. Now as per lens formula, 1 by V minus 1 by U is equal to 1 by F. So 1 by U is equal to 1 by V minus 1 by F. That is equal to 1 minus 1 by 10 minus 1 by minus 15. That is equal to minus 1 by 10 plus 1 by 15. This comes out to be minus 30. Therefore, the object should be placed at 30 centimeters on the left hand side from the optical center. Let us look at the next problem. A spherical mirror and a thin spherical lens have each a focal length of minus 15 centimeter. The mirror and the lens are likely to be. So when I talk about a spherical mirror, so here the focal length is given as negative. So if focal length is negative, what kind of lens it has to be? It should be a concave lens, because focal length is negative for a concave lens. If you remember the concave lens, parallel beam of light when falls on it, they all diverge, and when you try to extrapolate it in the backward direction, they meet at the principal focus. So therefore your focal length is negative in case of a concave lens. What about mirror? In which mirror the focal length is negative? It is negative in case of concave mirror. If you remember your concave mirror, it is somewhat like this. So that means your center of curvature is here and your principal focus is here. Right, so in this case also it is negative. So the correct answer would be both are concave. It says find the focal length of a lens of power minus 2 diopters. What type of lens is this? So what is the relationship between power and focal length? We know that focal length is equal to 1 by F. This implies that focal length will be equal to 1 by P, that is equal to 1 by minus 2, which is equal to minus 0.5 meters. So this would be the focal length of the lens. Now since F is negative, that means what kind of lens is it? It is a concave lens. Let us look at the next problem. A doctor has prescribed a corrective lens of power plus 1.5 diopter. So that means power of the lens is given as plus 1.5 diopters. Find the focal length of the lens. Is the prescribed lens diverging or converging? So how do I calculate the focal length? Focal length would be nothing but 1 by P. That is equal to 1 by 1.5. So from this we get 0.66 meters. This is the focal length of the lens. Now what do we see? Focal length is positive in this case. So what kind of lens is this? It is convex lens. And convex lens is a converging lens because it tends to converge the incident rays falling on it. Let us now look at the 10th problem. It says that a 2 cm tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeters. So in this case, focal length is 10 centimeters. For a convex lens, focal length will be positive. Now what is the height of the object? It is 2 centimeters. The distance of the object from the lens is 15 centimeters. So u is minus 15 centimeters. So we have to calculate the value of v and also magnification. Right? So first we will apply the lens formula. So using the lens formula we can calculate the value of v. 1 by v minus 1 by u is equal to 1 by f. So we can say 1 by v is equal to 1 by u plus 1 by f. That is equal to 1 by minus 15 plus 1 by 10. From this we get 1 by 30, or we can say v is equal to 30 centimeters. So this denotes the position of the object. So now we have to calculate magnification, and we know that magnification is equal to, what would be the magnification in this case? Magnification is equal to v by u, or equal to h dash by h, that is size of the image by size of the object. So let us first try to calculate the magnification using the image distance and the object distance. So now using the magnification as v by u, we get that v is 30 divided by u is minus 15. So it comes out to be minus 2. So using this magnification, so we found out the magnification. Now using this we can find out the height of the image. So height of the image h dash becomes equal to magnification into height of the object. That is equal to minus 2 into 2 centimeters, that is minus 4 centimeters. So the size of the image is 4 centimeters and the nature of the image is real and inverted. So what kind of image is formed? Real, inverted, enlarged, and the location of the image is 30 centimeters from the optical center. So with this problem we will conclude this lesson. I hope you got some idea about the phenomenon of reflection and refraction of light, and you also got an idea about how to approach problems based on spherical mirrors and lenses. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.